Our next top five case, I'll be handing it over to Abhishek to talk about Charlottetown Pollution Control Plant.
Thank you, Alex, and greetings, everyone. Thank you for being here. Let's walk through the feed-forward aeration optimization using Sentry. This is city of Charlottetown, our home base, my city, and we are at the treatment facility for the city. This treatment plant treats on average 45,000 population, but since it's a tourism city, the change in population is significant over the summers. With this, we have installed 8 sensors across the activated sludge treatment process of this treatment plant, and 2 of these sensors, namely the influence sensor that monitors the wastewater coming from the primary clarifiers into the aeration tank, as well as the effluent sensor that monitors the water going out of the secondary clarifier, are used for feed-forward aeration optimization. Whereas the remaining 6 in each cell of the aeration tank, we use it to monitor the biological processes and get some insights into it. So we are using Sentry as a feed-forward options for the aeration optimization. So there's always a question of why Sentry. So we know aeration is one of the most energy-consuming operation in activated sludge treatment. And I can confidently say that most of the treatment processes around the world are modification of this particular process. And the aeration is dependent on organic loading, the food that comes for the microbes, right? The traditional approach for measuring this is COD and BOD analysis, but these adds limitations on fast-paced approach and practical approach because it takes at least 2 hours to 5 days to get that value back. Currently, we are using dissolved oxygen or ammonia, which is a response variable and doesn't and kind of lack that predictive value and need a bit of help there. And this is where Sentry comes in. So Sentry's ability to monitor the incoming organic loading helps supplement the DO control and adjust it in response to the incoming load. So with keeping this in mind, we Sentry, in collaboration with City of Charlottetown, had this climate challenge fund where we had 2 objectives. One, the wastewater optimization to reduce energy, which is the feed-forward aeration optimization project, whereas the second one being using this opportunity to have a unique insight into the biological treatment process, right? How things change when inside the aeration tank. So first of all, on this process, what we did was we installed the system and monitored it for next 6 to 8 months. So you could see a beautiful, consistent diurnal patterns, weekdays high, weekdays high, weekend lows, and rainfall impacts in the signal. So with this signal, we also collected data from the treatment plant. So did this data collection, we did some DO analysis. For example, on the top right, you can see a pie chart where we see what the amount of time the DO set point is. You can see it's significantly over aerated or under aerated, and this controls around the set point of 2.5 mg per liter. So this puts a large energy saving prospect or availability. So what we did is we took this data and did the calculations on savings in energy, savings on cost, savings and opportunity to reduce emissions, which is a significant part of every municipality now. So moving forward with this, we gather further data, did sumo modeling, which is a kind of wastewater modeling, and kind of played around with what we can achieve with different DO set points. With this data, we bring in our partner, APZ Neuros, to code or assess or help us to implement this project because they are the experts on the blower side. APZ Neurons came into the picture and supplied industrial PC, which is called Advanced Aeration Control, which is a new technology of modal predictive control and helps optimize the aeration process using Sentry signal. What we did was we bought Sentry now into the SCADA of the treatment plant, connected through 4 to 20 MA. And at the right picture, you can see that small red box where I have highlighted the small industrial PC connected to the SCADA system. So when we did that, we installed the industrial PC, we bought the Sentry signal into the SCADA system, and now the control system is in line helping the treatment plants optimize their aeration since 2 weeks back. So yeah, so on this further note, with this information and data, now we have successfully installed the aeration optimization PC there. And now what we are doing is we are gathering information and data on this. And with which is patching day, we are improving the model for process control and evaluating the system performance with all the sensors that we had inside the reactive tank. And now we definitely will be using this results to showcase the benefits and feed forward aeration control using Sentry. And I will say expect something big is coming up in next couple of months. Thank you, Alex.
Thanks, Abhishek. This is one of our most exciting projects. It's not the least because it's where our headquarters is based, so it's very close to home for all of us who work for Sentry. So we're super excited to see how this project plays out over the next few months.